basic class of function. We have linear function. Linear function are function of the form of f of x equal mx plus b, where m is the slope and b is the y-intercept of the graph of f of x. F of x is an increasing function when m is greater than 0, and a decreasing function when m is less than 0. Let's get the graph of the linear function f of x equal 2x minus 3. Well, here we know that this graph have the y-intercept of 0, negative 3, and the slope is equal to, so here we have an increasing function. 0, negative 3 is our intercept. The slope is 2, so go up 2 over 1. So let's label our intercept in our next point. We will go ahead and sketch the graph. We want to write a linear function whose graph parallel to the previous example. So recall, given y1 equal m1x plus b1 and y2 equal m2x plus b2, y1 parallel with y2 imply m1 equal to m2. Okay. So the previous function that we just have here is y equal 2x minus 3. Okay. So this is our y1. So m1 equal 2. This leads to m2 equal 2. So I can write this y2 equal 2x minus b. Now we weren't told that what is the point that y2 must pass through, so we can't really calculate b here. So let's just pick one. It's just b can be any real number. So let's just pick one. So let y equal 2x plus 0. Right? This line is parallel with the previous one. Now write a linear function whose graph is perpendicular and pass into the y-intercept of the previous example. If y1 is perpendicular with y2, this means that m2 equal negative 1 over m1. So y1 equal 2x plus 2x minus 3. m1 equal 2. This means m2 equal negative 1 over 2. Then I can write the equation y2 equal negative 1/2 x plus b. We're told that y2 is passing through the point 0, negative 3. This means I can calculate b by replace the point 0, negative 3 into the equation. So negative 3 equal negative 1 over 2 times 0 plus b. Therefore, b equal negative 3. So y2 equal negative 1/2 x minus 3, and this line is perpendicular to the previous one. We have polynomial function. Polynomial function are function that have an exponent in our variable, and this exponent is of a integer. Okay. Power function, a function of the form f of x equal a times x to the b, for a and b are real number. If b is even, then the function is even. If b is odd, then the function is odd. Okay, let's take a look at this example. Describe the behavior of f of x as x approaches plus or minus infinity with phi equal to 0, then sketch the graph of f of x. Let's start with phi equal to 0 first, and then we go back and describe the behavior. I want you to see what the graph look like. It's easier to argue what it would look like in plus or minus infinity. So let's find the 0 first. We'll go part B first. If f of x with to phi equal to 0, I'll take negative 3x squared minus 5x plus 2, and I'll set that equal to 0. So 3x squared plus 5x minus 2 equals 0. We'll factor this. So 3x squared plus, well, two numbers multiplied together get you negative 6 and add up to 5. So that will be plus 6x minus x minus 2. Factor by grouping 3x times x plus 2 minus x plus 2. So this is 3x minus 1 times x plus 2 equal to 0. So the 0, x equal 1 over 3, and x equal negative 2. Okay. And go ahead and sketch this graph. Okay. To sketch this graph, this is a parabola. F of x equal negative 3x squared minus 5x plus 2, and we have parabola here. We first need to find the vertex. Okay. So we have what for the vertex? X equal negative b over 2a. That is 5 over 6. And we can calculate the value of f of x. And this value of f of x equal, this is negative, and we get this is 49 over 12. So to decimal, this is about negative 0.833, and this is 4.083. Okay. So the graph somehow look like this. So negative 0.883. So it's a little bit closer to 1, and 4.083 is closer to 4. So the rough sketch of the graph, negative 2 and 1/3. And this is a rough sketch of the graph. It is not accurate, so don't take it too hard. Okay. Now, as we can see here, we'll go back to part A. As x approaches infinity, okay, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. This makes sense, right? One way we can see that, well, f of x is a quadratic equation, and we have a negative coefficient. So negative 3 would mean the graph is open downward. So as x go to negative infinity, f of x go to negative infinity, and the same for the x go to positive infinity. Let's take a look at the next one. We have f of x equal x to the third minus 3x squared minus 4x. Let's first try to find out 0 first. X to the third minus 3x squared minus 4x equal to 0. Factor out x. X squared minus 3x minus 4 equals 0. So x minus 4 times x plus 1 equal to 0. So our zeros, x equals 0, x equals 4, and x equals negative 1. Well, now that we have the graph, let's see what will happen. How do we graph this? Before we graph it, we need to see the increasing and decreasing interval, whether the graph is above or below the x-axis. Here in this case, we only make a rough sketch of the graph, and it may or may not be, it's probably not going to be the most accurate graph, but it will let us know what is the behavior of the function look like. So let's take a look at part C. On our number interval, here's -1, 0, 4, positive infinity, negative infinity, and we want to see what happened to the graph, whether it is positive or negative in the interval. We have our factor that is x minus 4 and x plus 1. In the first interval from negative infinity to -1, x away negative, negative, positive, positive here. Okay. In x minus 4, this interval away negative, 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 positive, negative, positive, positive, positive. So this graph result in f of x is below the x-axis at -0, negative infinity to -1, above, below, and go back above. Okay, so let's put this on our graph. That is -1, 0, and 4. So the graph is negative and then positive, so it's something like this, and then go back down and up. Okay, so this is the shape of the graph. This telling us then, okay, then f of x at x approaches negative infinity, f of x is approaching negative infinity, at x approaches positive infinity, and f of x then approaches positive infinity. Transformation of function. You want to graph each function by not plotting point but stating with parent function and apply the appropriate transformation. Okay, so this will be shifted 2 units up, 1 unit to the right. Compare to f of x equal x to the third, and I will leave that to you to sketch the graph. Okay. This graph here, look, we have a negative. Let's rewrite this a little so you can see it a little better. Let's make it equal square root of -1/2 x plus 1. Okay, so we know that this is go up. Excuse me, let's factor this. Square root of -1/2 times x, and that is plus 1, so that is -2. Okay, so we can see that this is shifting to the left, excuse me, to the right 2 units. Now since we multiply by a negative, this reflects across the y-axis. And since we multiply this with a factor of a half, this graph is stretched horizontally by factor of c. by 2. Okay. And that is our 1.2.